Welcome back to the PhoneGap Essentials course on NetTuts Plus Premium. In this lesson, we're going to be having a look at PhoneGap's Storage API. The Storage API is actually based off W3C web standards. So the SQL Database API and the Local Storage API could actually both be used in a normal browser. Since not all devices support the W3C standard, PhoneGap has its own custom implementation. It makes use of the standards when it can, but for devices that don't support the standards, PhoneGap has its own implementation. But this all goes on behind the scenes, so we shouldn't have to worry about it. For any app to function correctly, we have to find a way to achieve permanence of information. We have to be able to remember a user's settings and other data that they've entered into our application. In this case, we're not talking about file storage. We're actually just talking about data storage. And for that, PhoneGap gives us two options. We can either store our information in a permanent web SQL database, or we can make use of local storage. Let's have a look at local storage first. Local storage is the simplest way to keep track of user data between app sessions. It's kind of like a web browser cookie. You have to define a key value and an actual data value. We can set a piece of data with window.localstorage.setItem. We choose a key, this is our variable name, and we enter in a value. To retrieve an item, we can create a new variable and load in a local storage key using window.localstorage.getItem. You can also remove items or clear out the local storage for your app entirely. Let's take a look at a quick local storage example, and then we'll have a look at database storage. Open up your index.js file and we'll get started. We're going to create a really simple app that generates random numbers and always remembers the last random number you generated, even after you've closed the app. In our device-ready function, we'll start by calling a new function we're going to create, test4number. We're going to start by testing the local storage. We're going to use getItem to find out if we have a value stored called big number. If the number doesn't return as null, it means that our app has already been used before and we've stored a number in there. So let's present that to the user. We'll print out a message to the user in the test zone inner HTML. Your last random number was, and then the number. If number is null, it means they haven't used the application before, so we'll give them a message to that effect. So let's give our user the ability to generate random numbers. I'm going to create an event listener for a click on the test zone div. On click, we'll call app.setNewNumber. Let's start by generating a random number. Here we're setting the variable number to a random number between 1 and 1 million. We use math.floor to make sure that it is a rounded number, an integer. Next, we'll print the random number to our test zone div, and then we'll store it in the local storage. With window.localstorage.setItem, we can set the variable big number to our random number. So let's have a look at this in the simulator. So as you can see, it's given us the message, you have never generated a random number. And if we click in the test zone div area, it's generating random numbers for us. Let's exit the app and see what happens. Your last random number was, and it's telling us the number. So that's how you use local storage. So now let's have a look at database storage. Everything starts with the open database method. You use this to open or create a new database. When you open a database, you need to pass in a name, a version, a display name, and the amount of space you want to dedicate to the database. If you pass in a name that does not yet exist, this is essentially creating a database. When you open or create a database, you'll be returned with a database object. All data manipulation and data searching that you do with the database will run through the transaction method. Using the transaction method, we can execute SQL queries on our database, but we don't actually pass in any SQL code in the method. We simply pass an error and a success callback and a method which will execute our SQL for us. If we look at this method that was passed with the transaction method, we can see that it contains 4 execute SQL methods. And it is here that you can execute SQL. We can create tables, insert new rows into the database, or we can also query the database. When the execute SQL method is called on the database transaction, it returns us an SQL result set. This contains the insert ID, the number of rows affected by our SQL transaction, and an object called SQL result set row list, which contains all of the rows returned by our transaction. This SQL result set list can then be queried by a loop, so we can retrieve all of the relevant data from it. So let's take a look at an example. Back in our index.js file, I've stripped out all of the code from before so we can start with a clean slate. Let's start off by opening up or creating a new database. I'm going to attach our database to a variable that I've defined in the initialize function. So app.db equals window.openDatabase, then the name of the database. This is the unique name, and I will use it in the future to refer to this database. The version number, a display name, and the amount of space I want to dedicate to this database. In this case, about 200 kilobytes. Next, I'm going to want to populate my database. I only want to do this once though, the first time we start up. So I'm going to test if it exists first. I'm going to make a new function called test_if_database_exists and block out a function. The easiest way to do this actually is using local storage. We're going to test a variable called db_exists using the local storage. Later on, when we create and populate our database, we'll set db_exists to true or 1. That way, when we run this test in the future, it will return true, that yes, the DB does exist. If exists equals null, we're going to create the database. If not, we're going to run a query on the database. So in our create database function, on our DB, we're going to run a transaction. Our transaction will be represented by code, SQL code, that you'll find in populate DB, and we have an error callback and a success callback. So here is our populate database function. It gets passed one variable, which is our transaction object, on which we can run execute SQL methods. The first one we'll do is to drop table if exists users. This is SQL code. If you'd like to find out more about SQL code, I suggest checking out tutorials on NetTuts. But for now, I'm sure we can get by. So we're testing to see if a users table already exists. If it does, we're going to drop it because we want to start with a clean slate. Then we're going to create table. Our table is going to have an ID, which will be unique, a first name, a last name, and an age. Next, we're going to insert one record into users, ID 1, Jason Green, 30 years old. And we'll insert another one, John Smith, 48. So now we just need to add in our populate error and populate success callbacks. If there's an error, we'll write a message to the test zone div. And in the case of success, we'll write a message as well, but we'll also set local storage db_exists to 1. This way, the next time we start up, we'll be running the query database method instead of the create database method. So let's check that out and see how it went. As you can see, we've gotten the message database populated. This means it successfully executed all of the execute SQL commands that were loaded from the transaction method. Now we're going to query our database to get back the information we loaded in. So here is our query database function. Let's start by alerting the user that we're going to make a query. Next, we're going to run a transaction on the database. We're going to be executing our SQL code in a function called query_db. And if there's a failure, we'll call query error. Here are our two functions blocked out. In the case of an error, we'll pass the error code with a message into the test zone div, and the query we're going to run is going to be executed here. So execute SQL, select all from the users table. The result of this SQL query will be passed to our success callback. So that's going to be the most important callback, where we're going to be retrieving the information from the database and writing it out to the test zone div. Since we know we're going to be using a loop to iterate through the results list, the first thing we need to do is find out the length. We're creating a variable called len, which is equal to results.rows.length. We'll also create a variable to hold our HTML. We're going to be printing a lot of different details to the test zone div, and it will be more tidy if we keep everything together in one string. And here is our for loop. In here we can build up a string containing all the information about our result row, and then we can add that to our test zone div. Firstly, we'll be adding the ID. We'll set the ID equal to results.rows.item ID. You'll notice that item is not an array, but a function that returns the row located at the index passed, in this case I. Next we'll add the name with the first name from our database, the surname using the last name from our database, and the age. And then we'll add it all to our test zone inner HTML and reset HTML variable so it can be used in the next cycle of the loop. So let's export that and see how it went. As we can see, it's worked fine. We've had our ID, name, surname, age all printed out from our two entries that we created. We can exit the app, come back, and the entries are all still there because they are stored permanently in the database. Well, that's all for now. Check back in for the next lesson where we'll be discussing the file system. Ciao!